Welcome back. This is still lecture 8, and we're working with project 10 in GRA 6036. And we've come to exercise F here. So now we have to use the previous point to conclude that beta naught is the average, beta naught hat is the average wage for people with looks below or equal to 3, while beta 1 hat is the change in wage when you go from those with the good-looking people to the not so good-looking people. And well, I mean, we've already seen, we saw in the last exercise that these two were equal to the same number and these two were equal to the same number. So, I mean, from this we can conclude that, so this is exercise F, that, I mean, since this is 0, clearly beta 0 is the mean of those with looks assessed to be below or equal to 3, while beta 1 must then be the mean of the mean wage in the good-looking group minus the mean wage in the not so good-looking group. So yes, they are the same number. And then in this exercise we're asked to try to, if this is always the case in such a model, I mean, or if it's just some fluke with this particular data set. Well, it is always the case, and showing that there's a good exercise that you should try to solve before looking at my proposed solution to that exercise, which is here and which I'll post on It's Learning. So I mean, read through this and make sure that you understand all the steps. And it really, I mean, to show this, we only use things that we've been working with. So there's a lot of summation going on, of course, and but you know, we need some different symbols and some things that we might not be used to, but it's the same as what we've been doing many times, but it's a good exercise. So try to solve this, try to show that, I mean, the conclusion here is that beta naught is equal to the mean of those who have x equal to 0, while beta 1 is equal to the mean with those with x equal 1 minus the mean of those with x equal to 0. So before you look at this, try to solve it yourself. Okay, so then we'll go to exercise G, and in exercise G we're asked to subdivide, find the indices of 4 different groups. So we'll have good-looking and not so good-looking males and good-looking and not so good-looking females. So that will make 4 groups, and then we must use the and or the and operator that we were working with in the 2 videos ago. So to find, so in this data set we have the call names of in this data set. So there is a variable called female, which then typically takes the value 1 if the observation is female, and 0 otherwise. So yes, that's a 0, 1 vector. So to find good-looking females, we can ask when this is equal to 1 and when beauty looks is bigger than 3. Okay, so that will give us a true-false thing for the first group, and then we have the not so good-looking females. So that's this group, which I should be in line here, so we should do this. And then we do the same thing for the males. So you have the good-looking males. So that's when it's equal to 0 and BL1. So now they are named the same thing. That's unfortunate. So we should say not so good looking. NSGL, good looking, not so good looking. And then, okay, so NSGL male will be female equals 0, and then looks below or equal to 3. So now none of these, I mean, to make sure that we did everything wrong, since you can't be in more than one group here, we should make sure that we can make sure that none of these are true at the same time. So then we could do this and this. So okay, I don't know if I need a parenthesis here, but to be and this and the last group. So now they ought to be all false. They look to be all false, but we can sum them to be sure. So the sum should be 0. So, well, it seems that we did it correctly. Okay, so we then need to find the indices, or well, maybe we don't need to, but when we could. So then you do good-looking female, and then you could index like this, and then that will give you the indices for the good-looking females, and you can do the same thing for the not so good-looking females, and index. So like this, and so on. So now we have identified. Well, so okay, let's do this a little quickly. So that is good-looking male, and then we have the not so good-looking male index, which is then this and so now we have all the indices. I think this will be redundant because it suffices to have only the vectors with the true false values, but you know, we could do it, and we could of course have just taken the use the which function directly here in the first place. Okay, but now we have done what the exercise asks us to do. So now the question is, how many people are there in each group? So then we can use these and sum them. So that 144 good-looking females. There are how many not so good-looking females? 292. And then there are among the good-looking males, 239. And then we have among the not so good-looking males, there are 585. Okay. In the next exercise, we are to compute the average wage in each of these 4 groups. So, well, now I notice one thing, that I started using the old dataset where I hadn't deleted that observation. So let's just replace this with a new dataset and recompute. So 2, 2, 2, and 2. And we rerun it. So then one of these groups, the first group, will change its number to 143. Okay. So let's compute the average for the 4 groups. So then we need the beauty2 dataset, and we enter into the wage variable. So wage, and then we do square brackets. Now we can insert the indices, or we could just insert a vector with a true false value, so it will give us the same thing. Well, to pick out the wages of the good-looking females, it's here. So then we have this, and we do it for all the groups, so it's looking male, and then the last group is not so good looking males. So, and then we must wrap this into the mean function like this, and then we can compute the 4 means. So I mean the first thing that strikes you when you do this is that the men make almost double what the females make. Okay. Oh, and so, well, that's nice that we did this, but we were supposed in this exercise to compute the log wage. So we could then just take the log and recompute. And since the logarithmic function weighs down in a sense big values, it's not as easy to see the difference in wage between females and males when we have taken the logs. Now they seem to be closer to each other. So I mean that is because let's plot the log function. So take a sequence from 1 to 10 with a step size of 0.01, and then you could plot the log function u and stripe the line width, and we need that the type, so to not get the type is a line, or if we don't have the right type we'll get dots. Do this. So I mean this is the reason for which it's harder to see that. So we could plot u to see this, why they seem to be closer to each other after the log transform. So okay, this is why. Okay, so that was exercise age, and in the next video we'll do more exercises.